Hello, 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 my beautiful wintergreen babies. Today we are going to be working on speed graphs. Okay, so these are graphs that they pop up on your tests and quizzes. And what they're asking you to do is they're asking you to describe the motion that is happening in the graphs. Okay, so we're gonna make 8 or 9 of well, no, let's say we're gonna make about 7 of these graphs today, and I'm gonna show you, different types of speed graphs. There will be speed graphs that are going to show you when something is moving at a constant speed, when something has stopped, when something is slowing down, when something is speeding up, when something is turning around. Okay, so I'm going to show you all kinds of different ones, but they're all going to have the same kind of format. So I have graph paper here. If you don't have graph paper, that's just fine. We're going to start with the first graph. So what I'm going to do is I'm going to draw this. I'm going to draw a line going about 5 blocks down and about 5 blocks over. Okay, and if you don't have graph paper at your house, that's fine. You can just do this on regular paper too. Okay, so what you need to know is that the time is always listed at the bottom of the graph. And I like to tell my kids to remember that because time marches on. Time doesn't jump up, time marches on. Give yourself that little note up here in the corner. Time marches on. Okay, that's something you might have heard your parents say. So time comes across the bottom. So you'll have a starting point. The starting point will be here, and then the time will be increasing as you go. And time does not stop. Okay, it keeps going. We do not live in Back to the Future. You cannot stop the time. So time continues to march on. Then up the other side of the graph is the distance. Okay, the distance that something has traveled. Okay, so time is always going to be across the bottom, distance is going up the side. So what I want to show you first is I want to show you what a graph will look like if it is moving at a constant speed. So constant means it's not changing. So if you drive to Raleigh at a constant speed, you might be going 55 miles an hour, and your mom might set the cruise control. So down here, you're going to write hashtag cruise control. What that means is your mom has a button on the dashboard that she can press that makes it so the car is traveling at 55 miles an hour. She can take her foot off the pedal. It just goes, okay? Constant speed. So when something is moving at a constant speed, so what that means is after 1 second, it's traveled 1 mile. After 2 seconds, it's traveled 2 miles. After 3 seconds, it's traveled 3 miles. After 4 seconds, it's traveled 4 miles. So it is moving 1 mile a second. So your line is, and I wish I had a ruler, but I don't. So I'm going to just use this piece of paper right here. So your line is perfectly straight, okay? Because for every time increment, it's moving the same increment for the distance, okay? Now, this could be 50 miles per hour, which would be 100 miles for 2 hours, which would be 300 miles for 3 hours, whatever. So, but it is moving up at a constant speed, straight line, okay? So as time moves on, it's going the same distance each increment of time. So this is a constant speed. This is called our cruise control. Constant means it doesn't speed up, it doesn't slow down. This is cruise control. All right, so next we're going to do a different one. We're going to do this one, we're going to draw the graph looks the exact same. So 5 blocks down, 5 blocks over. And as always, time is at the bottom because time marches on, okay? Time is shown at the bottom. Then up the side, we've got distance. This is how far it traveled in that amount of time. All right. So for this one, we are going to do a stationary model. Now, stationary, you know from learning about stationary fronts, is when it is not moving at all. Stationary means not moving. So how could I show that something is not moving? Okay, so I want you to pretend, I am gonna write some times down here. So I'm gonna write 12 a.m. I'm gonna write 1, 2, 3, 4, 5, and 6, okay? So remember that time is marching on, okay? And I want you to pretend that this is, we're gonna just use, we're gonna use a kid in my class. Let's use Zayden, okay? Well, actually, I don't have a Zayden this year. Let's use Zaylin. I do have a Zaylin. So let's go ahead and come up here, and we will put him right here at 12 o'clock. We will say that he has gone 2 miles. So right here at 12 o'clock, he's gone 2 miles. Put his dot. Well, he's feeling kind of lazy. He doesn't feel like moving, so he decides to lay down and take a nap. So at 1 o'clock, he's still gone 2 miles. Then he decides to eat a sandwich. So at 2 o'clock, he still has not gone anywhere. Then he pulls out his Switch, his Nintendo Switch out of his pocket, and he plays video games from 3 o'clock to 4 o'clock to 5 o'clock. So as time marches on, he is not moving at all, okay? He is staying in one place. Now, time is keeping on going, but no matter what's happening, he is in one place, okay? We're going to call this hashtag flatline. Hashtag flatline. He's not moving at all. Flatline, like he's dead, okay? Like a flat line on a hospital, at the hospital. So he's not moving anywhere at all. Time is marching on, and his distance is neither increasing or decreasing. This is a flat line, okay? All right. Our next graph is going to be speeding up, accelerating. So we're going to come down here, and we're going to draw another graph. So here we go. I'm going to draw 5 down, 5 over, and you don't have to put this on graph paper. You can write this right in a little notebook. Always at the bottom is time, because time marches on, baby. Up the side is the distance traveled, D-I-S-T-A-N-C-E, okay? Time is always listed at the bottom, distance is up the side. So if you want to show that something is speeding up, I'm going to write this right here. Speeding up. This is also known as that fancy science word, accelerate. Your mother might, or your dad, when they press on the gas pedal, they are pressing on the accelerator, okay? So what would your graph look like? So what your graph looks like is it will start off kind of like this, and then it will go, woo. It'll make an upward curve. Okay, so what has happened is your parents were traveling at a constant speed, that straight line, and then they started going faster, and it took them, they went more of a distance in less amount of time. Okay, so for example, if this was 1 mile, 2 miles, 3 miles, 4 miles, 5 miles for your distance, and your seconds was, let's just say that this was 1 second, 2 seconds, 3 seconds, 4 seconds. This is just, obviously not going to work out in reality. But what I want you to see is in the first 2 seconds, they traveled 1 mile. But in the next second, they sped up, and they were able to go almost all the way up to 5 miles in the next second. Does that make sense? So they are going much faster because the graph went up. I like to call this hashtag, this is the gas pedal. If my kids were here, they would call this hashtag skirt skirt. They sped up. They went super fast. Vroom, sped up. This is where Mama hit, right here is where Mama hit the gas pedal. The gas pedal. It was going a constant speed, and then she put the pedal to the metal, baby, and y'all shot off. Now, the exact same thing goes the other way. Draw another graph. 5 down, 5 over. If you are on notebook paper, that's just fine. Okay. Always the time is across the bottom and the distance is up the side. So if you've got time and distance and you want to show that they slowed down. So let's say that Mama was driving, and then all of a sudden she saw a turtle in the road. You would see it tip that way. It would go this way. The time, there would be less distance. Well, actually, this would probably be that she slowed down too much. Because now this has got her stopped, doesn't it? We don't want to show that she's stopped. Let's just go, we don't want to do that much because now she's stopped. Because you see, once she achieves a flat line, she stopped. So let's just go like this. Now, she is starting to slow down, okay? All right, and so she's no longer going at that straight line at that constant speed. She's begun to slow down, where she's traveling less distance as time goes by, okay? And we're gonna call this hashtag the brake. This is when she pumps the brakes. This is showing a slow down. Okay? All right, so time is going on and the distance traveled is becoming less and less as time goes on. All right, so our next one, I'm gonna show you turn around. So come down here, right? 5 going this way, 5 going this way. And this one is one that confuses kids because, you know, we haven't really talked about the location yet. Okay, so down here, you're going to write time because time marches on. And up the side here, you're going to write distance. All right. So what I want to do on this one is I want to label a 5-mile race. So let's say that you've got a 5-mile race, put a 0 down here. This is the start. This will be mile 1. This is mile 2. This is mile 3. This is mile 4. This is mile 5, also known as the finish. Okay? All right, so you've got this, the distance is listed on this side, so you've got the start to the finish of the 5-mile race. Now, let's say that this is, let's just do a kid in my class. Let's say this is Jayla, and she decides to run this race. So what she's going to do, she's going to run, and time is going to go by as she's running. She's going to run all the way to the end of the race. And so the whole time she's running at a constant speed. So this is a straight line. She's running at a constant speed. Then she gets there. She stops for just a little break. She rests right here. This is where she rests. And then Jayla runs back home. Okay, so she runs back home to the start of the race. She runs all the way to the finish of the race, and then she rests for about a second. Well, she rests for, let's give her a little while that she rests. She rests for about an hour, and then she runs back, okay? So it takes her this is 1, 2, it takes her 3 hours to run 5 miles. She rests for about an hour between hours 3 and 4, and then she comes back and she runs back for the second half of the race. So this is 6, 7, so she comes back home at 7.5. So it takes her about 7.5 hours to run 5 miles and then run back to the finish. So this is called what I like to call the turnaround. This is a turnaround graph. She ran all the way to the end and then came back to beginning. This is the start and this is the start again. So start to the finish and then back to the beginning. Start to the finish and come back to the beginning. We're going to call this hashtag bounce back. Hashtag bounce back. Okay, so these are the five most basic types of speed graphs, okay? We're going to talk more about different types as we go, but these are the 5 basic ones that you're going to see, okay? So if you've got a constant speed, you got a straight line, constant speed. No up, no down, just a constant speed, okay? If it is a flat line, a stationary graph, it is not moving. That means that time is marching on, but you are not. Okay, so this is a stationary graph. So the time is moving on, but the distance is not increasing or decreasing. This is the gas pedal. You speed up. Okay, so you'll see the swerve to the top. Now, if you have different arrows, so if you see another arrow on the graph and it's like this, and they ask you who is going faster, this kid right here is going faster because he's traveling more distance over less time. So this is faster. Same thing here. If you have, they show you 2 lines and you've got one going like this, and they ask you who's going slower, this kid is going slower, okay? Because he's traveling less distance over more time, all right? And then our last one is our bounce back. You start at the beginning, you run to the finish line, and then you come back. You need to understand that the bottom down here is, it's relating to the distance. So you're running to the finish line and then coming back to the start line, because that's when you're back at mile 0. You're at mile 1, 2, 3, 4, 5, stay at 5, then 4, 3, 2, 1, 0, back at the start. All right, love you guys. Take a picture of this, send it in to your teacher for a grade or video. Bye.